All right, today we're going to talk about topics 8.6 and 8.7. We will get as far as we can today. First, a little bit about 8.6 is sometimes curves intersect at more than one point. All right, and that involves our limits of integration. So if we're finding the area of this region between these graphs, and I've got those graphs shown there, write the integrals, then calculate the area. Well, we need to find these limits of integration. All right? So we need to set these two functions equal to each other. And solve them. All right? And as calculus students, we should be able to do this fairly quickly. We get everything on one side, and we have 2x cubed minus 8x equals 0. We get everything on one side. Pull out a 2x, and we've got x squared minus 4. And if we solve that thing, we get 3 zeros. X equals 0, 2, and negative 2. 3 zeros. So what we have to do is we have to set up several integrals. All right. We need an integral from negative 2 to 0. All right. And if you look at our function here, when we're going from negative 2 to 0, all right, we have to remember which function is which. Okay? And in this case, the quadratic is my orange, so it needs to be on top. So I need to do x squared plus 4x minus the cubic. All right? But there's something significant here that we need to do. If you look back at my graph here, this whole area, this is why we have to know our graphs. This whole area is below the x-axis. So we need to do the absolute value of that thing. All right? And so when this is just that one part, so then I need a big plus sign. So add 2. The integral from 0 to 2 of now we flip it. And this one we do not need to do absolute value because the whole thing is above the x-axis. All right? And so we could, this problem we could do algebraically, we could do it analytically, or we could do it with the graphing calculator. I'm just going to tell you that this winds up being 8, and this winds up being 8. And we get a total value of 16. Regardless of which way that you do it, we're going to get 16. All right? Now, topic 8.7 is where we start getting into some three-dimensional regions. All right? Three-dimensional regions. Find the volume of the shape with a base bounded by the circle x squared plus y squared equals 4, and cross sections that are squares. Notice we're talking about volume now, not area. So, let's first look at what we've got here. We've got a circle, and its radius is 2. All right? We know that the radius is 2 from our basic formula of the circle, but there's something else going on here, and we almost never work with a circle in this form. We typically solve it for y. So if I solve it for y, I have y squared equals 4 minus x squared. And so y equals plus or minus the square root of 4 minus x squared. We will need that in a minute. All right? Now, what is happening here? Sticking out from this base, the circle is the base of our three-dimensional figure. Sticking up from this, three-dimensionally, if you think coming out of your computer screen or coming out from this board, are Scrabble pieces. If you think of the game Scrabble, we have the letters from the Scrabble game sticking out on edge from this circle. And so every one of these things, I will draw a Scrabble piece over here. Every one of these things is on edge, sticking out three-dimensionally. All right? And if you think of the way that we find the volume of a Scrabble piece, it's side times the height, length times width times height, but the sides are the same. All right? So the volume is side squared times the height. Now what we do is we're going to cut a whole bunch of Scrabble pieces and make them infinitesimally thin, which means the height is going to be dx. The height is represented by dx. Now, so we've got the volume is s squared dx. What we are doing now is we need to come up with an expression for this side. And if you look back at our formula for the circle here, half of one of these sides is the square root of 4 minus x squared. It's the function value. All right, that would account from here up to here. But that's only half of it. So there's another half down here. So we could say that the side length is 2 of those. 2 times the square root of 4 minus x squared. That is one side, that is these sides of our Scrabble piece. And we're adding up, which sounds like an integral to me, we're adding up an infinite number of Scrabble pieces. So this is going to turn into, let me insert a blank screen here. This is going to turn into an integral. And remember, we had s squared dx. So we now know what s is. In this case, the s is 2 square roots of 4 minus x squared. That whole thing is being squared dx. What are my limits of integration? Well, it's a circle with a radius of 2. So it's from -2 to 2. And so from this point on, it's normal. All right? But it's the setup that I wanted you to see. Again, remember that we're basically just doing side times a side times the height, but we're calling the height the dx. All right? And then we would just finish our integral from here. Obviously, this thing cleans up a little bit when I square it. I can bring the 4 out in front. And I'm really just integrating 4 minus x squared. All right, in that case. And we're going to stop there for today and continue this video tomorrow.